Hi there, and welcome to Context Free, where we talk about programming languages. Today, I want to talk about comparing Jonathan Blow's Jai language with the Odin programming language, about which I interviewed Ginger Bill, the creator of the language, last year. Meanwhile, Jonathan Blow is the creator of the video games Braid and The Witness, and he's been working on a new programming language since 2014, since he got tired of using C++, and he's simultaneously making a Sokoban video game while creating Jai. Jai is also not necessarily the final name of the language. And recently, a subscriber to the Context Free channel offered me a beta key to be able to join the slightly increased beta size for Jai, so now I have access to it. Meanwhile, Odin started in 2016, and it often gets compared with Jai because in some ways it looks similar, and it has some similar features as well. But the point today is to see what is in common and what's different to a certain extent with the amount of investigation I've been able to do so far. And I haven't closely followed the evolution of Jai, but when the features look similar between the two languages, probably Jai had it first since the language started first. Or alternatively, they might have come both from the same previous source of other languages before either. And note that Ginger Bill does credit various programming languages, although Jai is not always listed in the top. However, if you go to the Odin Wiki, you will see some comparisons of things that the languages have in common and things that are different between the languages. Also, on the Jai Discord, I recently asked, what are the key differences you'd like to emphasize if you gave a TLDR to someone who says they programmed in Odin and Jai for years and that they have almost nothing in common aside from syntax? And even the syntax varies quite a bit, as we'll see. So what they answered was, said there's module package system differences. Odin has a much more strict type system. Jai has metaprogramming. Odin has pattern matching switch statement with accompanying ergonomics with tagged unions and any. And those are what they said came to mind most. A different person on the Jai Discord said that they thought the implicit context and type info were very similar between Jai and Odin. So, it's an interesting topic, and perhaps a spicy one, but I'm going to give a non-spicy answer. We're just going to take a practical look at the similarities and differences that I've been able to uncover so far in my own exploration. And for the programs I'm looking at today, the programs I previously wrote in Odin for my channel, and I converted these programs to Jai to be able to do some comparison. And this program here doesn't have a lot of meaning to it. It just tests function overloading, or procedure overloading, as Odin and Jai both like to refer correctly to their side effect, including procedures. So here I have defined two different struct types, A and B. Then I've defined a bunch of procedures that handle different variations of these two data types. They don't use the content, they just print out things so we know which procedure got called. And Odin has this notion of overload sets. So you can say everything in this set that have unique names, I'm going to also refer to as say as an overload. And here's a generic function with generic types $x and $y that calls say in both directions on those. And down here in main, I just call say AB and say swaps AB as well. If we run it, we get AB, AB, BA. Looking back at the top and switching over to Jai, we see at a glance that something's changed, but it also looks very similar here. And it's actually going to be easier to see by looking at a diff between the two. So some of the differences we see here are that a package declaration is used in Odin. The imports look a little different, and this octothorpe pound hashtag symbol will show up a lot more commonly in our Jai than in our Odin. The struct definitions are the same, and these definitions are fairly similar, except that Odin uses the proc keyword where Jai uses nothing. We also have prefixed our print function with the module it came from. You can do similar things in Jai, but a lot of the defaults seem to be just import it and use it, so that's what I've done here. Note that the syntax for the generic function is very similar with the dollar signs. Only Jai has direct overloading as opposed to this explicit feature decision not to have direct overloading and instead have to be explicit about it. That exists in Odin. We also notice that semicolons are required in Jai, but not in Odin. And also from a style guide perspective, Odin uses tabs for indentation like Go as opposed to the spaces that I've seen in the Jai programs that I've looked at. So those are some of the differences we've seen. Let's go ahead and run the Jai version though, just to prove it works. And I'm purposely using their own x64 backend because it's supposed to be faster. And Odin is also working on a custom x64 backend, but I haven't tried it out yet. Anyway, we got a bit of verbosity here, including timing on the different stages of the compiler, but we get the same AB, AB, BA output. Let's look at the next example, which is multi-line strings, and also multi-line comments, which nest in both odin and jai. Meanwhile, here in jai we have here docs for multiline strings, and there's our pound symbol again. Whereas in odin, multiline strings are with a backtick. I can also assign a constant to some data here. This is a 1 pixel transparent GIF. And since these have to be constant, I presume that this is being evaluated at compile time. Just a feature for expanding strings in odin that works out. In jai, however, I'm taking advantage of the runtime code execution and a bit of metaprogramming, although it gets way more involved than this if you want to. So I've called the join function, which joins strings. This is auto-casting to an array of bytes, which is what add global data needs, and which I'm adding into a read-only section of the executable so that it can be used later. Now this is obviously more work than I had in odin, but it's also more flexible, and I could have made helper functions to simplify this. So it comes down to a question of what do you want your language to have? And odin has purposely not got the same metaprogramming features that jai has, and different people might have different preferences in these kinds of feature sets. So let's go ahead and run this. I'll run jai first, so we get our verbosity behind us. Then I'll run odin. In both cases, we have our multi-line string output and the number of bytes in our single pixel animated GIF. We also, in both languages, could load at compile time a separate data file into a constant inside the program. In odin, we actually do see a pound symbol here now for load pixel.ping. It's equivalent to this because this is the data that's in that binary file. In jai, it's less convenient again, though I could perhaps make a convenience function. I've read an entire file and cast that to a byte array, placed it in read-only global data for use in the final executable. And this pound run in jai means evaluate this at compile time. So run these again. We get the same output as before. And before I move on, notice that neither of these is trimming off the indentation. In the case of odin, we get more output, presumably because of the tabs in our indentation. Neither of them is auto-stripping that for us. Presumably, I could do some compile time evaluation in jai to get rid of that indentation. And diffing the two, we see here that because of the excess work in jai, it's actually longer than the odin. But again, presumably, I could make helper functions that would shrink it down some if I were to do this over and over again inside of my program. So we get to see some of the differences in the purposeful design decisions made by the creators of these languages. So let's move on to the next program, guessing game, which is, the guess a number between 1 and 100, and you do a human in the loop binary search. Just to see how it works, let's run it. Guess a number between 1 and 100. 50, too low. 70, too high. 60, too high. What if I mistyped something? Oh, I didn't understand. So 60 was too high. Let's try 55. Too low. 57, 56. 56 is the answer. Finished in 6 guesses. Total input errors 1. We're not going to look in detail at how this program is structured, but we'll see some of the things here that are going on. And in fact, let's jump straight to the diff between the languages and get rid of our terminal for now so that we can have more space to look at the diffs here in this more involved program. In our ask guess procedure, we have multiple return values in both odin and jai. And there's probably semantic differences I'm not going to look into today, but we'll look at some differences here. In particular, note that odin has the one-line assign values and do an if condition, which we also have seen in Go, for example. But if that exists in jai, I failed to make it work correctly. So I have a read first, then a check. And in terms of these return values, they're named in both cases, and they don't have to be named in either. But because it's named in odin, it means this is actually a local variable that's already been defined. So this OK here is actually setting the value of this OK variable. And then when I return here, I'm returning only the result. Alternatively, down here, result has the default value, and I've only forwarded the OK of false down here with this explicit return, but without the values because I already set it previously. On the other hand, in jai, the named return values act like named parameters. You can name them on your return if you want to, or you can leave them positional. And both languages allow you to name your parameters on calling as well. So in both cases, we have some symmetry between input and output parameters, but what that means is different in odin, again, where these are declared variables that can be assigned values, versus in jai, where they are just output parameters that exist only when you're doing a return. Looking at syntax differences, in odin, everything is a for looping, whereas in jai, you have your expected while true. And this is a purposeful simplification of the syntax space in terms of keywords that was made in odin. versus presumably familiarity here in Jai. And these are kind of decisions you can make when you're making your own language. Now, something unfortunate that I see in Jai here is that it doesn't realize that because this is an infinite loop, that it can't exit the function except through these returns. And it complains at me if I don't include an extra return after the loop here. That might be improved in the future. Both these languages are under development. Now, something else I want to focus on here, which I find very interesting, is this rand thing. For explicit control in this program, I was passing in a rand instance for generating random numbers. And in Jai, we're actually doing the same thing, but it's an implicit parameter. Both languages have a notion of context, such that for the standard calling convention, there's actually a hidden parameter here, which is the context, sort of like the hidden this in some object-oriented languages, except in this case, it's just being passed down through all procedures and provides you a way to hierarchically, throughout your call stack, control the behavior of things you're calling. So there is a hidden random number generator that makes it look like I'm using global random state, but I'm not. If we look at random.jai, we see here this add context thing. And all the definitions of what goes in the context is defined in user space through this add context thing, as opposed to in Odin, where there's a fixed predefined context for things that seem likely to be useful. And I can imagine pros and cons again. There's currently no smooth way to deal with conflicts in naming for adding context, for example, in Jai. And they might work out something about that in the future. It's just an example of the kinds of consequences that come from different design decisions. Because different people design these languages, and they made different decisions based on whatever influenced them and their experience. We see very different pointer dereferencing between the two languages as well. Also, I find that the standard library for Odin is probably a little bit richer for a lot of basic things. So for example, I just had a read into my buffer, allocate as you go for a line, and there was no such thing that I could find in Jai, where they said they actually deprioritized worrying about command line interfaces for meanwhile. And so I used a fixed buffer size. And there are pros and cons to this in terms of whether you want to have a fixed buffer or not, but just pointing out what's available in standard library in different areas, for example. And something else I want to focus on before being done here as well is that Odin and Jai and Zig and maybe other modern systems languages have focused on the idea of parameters being at least shallowly const by default. So for example, if I try to run these programs, let's do Jai first this time for kicks, we see an error about trying to assign to a constant. Same thing in Odin. However, I can get the address of my parameter in Jai, but I can't do the same in Odin. I cannot take the pointer address of game, which is a procedure parameter. And maybe this is just something they'll change in the future in Jai, but it also might be more fundamental to how they look at types and what these things mean. So let's hide that again and move on to our last example, which is my recently used fake web scraper, where based on contents of the URLs, I pretend I'm reading things off the web. So I can explore error handling, missing data, and so on and so forth. I had a previous video even where I went into a lot of monads with Haskell for this. So here we have our Odin, and here we have our Jai. And we'll find that when we get into the comparison here, there are many more differences between the two than what we saw perhaps in even our previous examples. We notice semicolons instead of commas for our struct members and our struct definitions. But a more interesting thing is that I defined maybe, like I've optionally have something or I don't have it for a value type here. I defined it myself in Jai because there wasn't really any built-in maybe like there is in Odin that has a lot of the semantics you might be expecting from a maybe. And I looked at various options for doing this and eventually had a recommendation from the Jai Discord just to make my own simple struct with an exists and some kind of value, which is generic. And in this case, they recommended, and I just went along with it, of defaulting it to an undefined value, which might be faster to execute in certain circumstances. I didn't think hard about whether I totally agreed with that, but I went along with it for now. In both languages, otherwise, you default to 0 values. And the undefined value for initialization in Odin is actually also the dash dash dash. But once I've defined my maybe type, using it looks similar, at least for the type name, but actually using it later, like interacting with it, we'll find is very different. So here we're reading documents, or pretending to read documents. And I was in the mood for sort of a functional look back when I was working on this program, even though Odin's not a functional language. And Ginger Bill, even when he reviewed this code of mine, he said, well, I wouldn't do it the way you did. But in any case, I chose to do this in a functional fashion where based on the contents of my strings, using the value if something else something, which is similar to how you did this in Python for your ternaries. I create a struct instance literal with either no content or an empty head, or a head with an empty title, or a title that has text in it. As opposed to in the Jai side, where we can do struct instance literals, but only if the values are constant, which is the current design decision inside of Jai. But it means if I want to create a struct instance with non-constant values, then I have to create an instance first and then add values to it. So I do sort of progressive, hey, do we have a head? If so, allocate it, and so on and so forth. Also note that I chose to use the temporary allocator with this T in Jai, which is something you presumably free up at every frame or cycle of your program execution. And I use the standard allocator in Odin, which might not have been the best comparison, but this is how I did it previously, and I kept it along. But it makes the comparison between Odin and Jai a little bit off here. Note that again, I'm a little bit more efficient here in Odin by having struct instance literals that are missing in Jai, although I can initialize the constant values up front. And maybe you prefer this, so you can see, oh, it's a struct instance literal. It must be only constant values that were known at compile time. That's currently the design decision there. And here in Odin, because I used the feature of assign and test all in the same if, I ended up wrapping across multiple lines, as opposed to in Jai where I ended up doing it on its own and it fit on one line. So as a sort of side effect of having more features, I happen to write longer code. But you could obviously choose to do it differently if you want to. Perhaps more interesting is down here in is title non-empty, where we're just evaluating things about the supposed document we've read, where when I'm dealing with null pointers or with maybes, I treat the empty case as nil. And the overall process seems much more straightforward in Odin than in Jai to me in this case. And here in Odin, taking advantage of or return definitely made it a lot shorter than the Jai example. Meanwhile, down in main, I'm looping across supposed fake URLs and pretending to load them and reporting on them. Each time through my loop, I'm clearing out the memory that was allocated during the previous run of the loop, where we see both have defer, which has been a fairly popular design decision since Go, although these languages have different semantics to it than Go does, happily. And in the case of Jai, again, I'm using the default temporary allocator, which exists in Odin as well. And in fact, for better comparison, Ginger Bill recommended I use the temporary allocator. I just didn't update it myself here. And it's also interesting is the default temporary allocator in Odin is a ring buffer, which has very different semantics than the default temporary allocator in Jai, which is a linear allocator, which will act a little bit more like an arena. And in my previous coding of this program for Odin, I did use an arena, which they have in the standard library, and it's a little bit more sophisticated than just a linear allocator, including the ability to, at different levels, like say at a nested loop, I could actually control just the reset of the allocated space for the portion used in that loop in a sort of hierarchical fashion across my call stacks. So nested loops and the growing arena in Odin, which is part of standard library, can be very useful and efficient for certain kind of use cases. Even though I'm not taking advantage of that feature here, because I only have one loop and nothing nested where I'm managing memory separately. Let's look what they both look like. I think I'll run actually Jai first. Here we see if we access a good URL, we get a summary where we have a non-empty title and we were okay, versus an empty title that was okay, or a missing title that was okay, or simply an error condition that wasn't okay. And in the Odin case, we have more straightforward output. And interestingly also, we have unlabeled struct outputs in Jai and labeled struct outputs in Odin. And who knows, maybe this might get improved in the future. This is the current behavior. But in any case, the inherent notion that Odin has of something being a maybe gives a simpler output here. I don't have to see all the extra booleans from my struct. And maybe I could have customized this. I haven't dug deep enough into Jai to know how. But this is just out-of-the-box behavior with maybes in Odin that give a simpler and cleaner output. And quick comparison again, like I said, with the version that Bill took a look at when I discussed it with him. He recommended using switch and using a more imperative strategy versus what I'd done in my version. And he also recommended using the temporary allocator, which has a free all context.temp allocator to match what we saw in Jai with the reset temporary storage. So this would be a closer match in that regard. Meanwhile, I hope this has been fun, and I'm not going to say which language I like better. If I have to give a quick high-level summary of the focus of the two, I would say that Odin has more out-of-the-box comfort, and Jai has more empowerment for the user. But we'll see how they evolve in the future, and I'm grateful that Jonathan Blow created Jai and kicked off sort of an interesting wave of systems languages. And I'm grateful that Ginger Bill has been working on Odin in public meanwhile also. And I look forward to Jai coming out as open source in the future. These are exciting things going on. And meanwhile, if you liked the video, be sure to subscribe. Bye, y'all.